Hello, we are on video number 2 for percents, and we're going to start on these application problems where we have to figure out how to set it up based on whatever directions we're given the problem. This one's about masonry. On the basis of past experience, a contractor expects to find 4.5% broken bricks in every truckload. If he orders 2,000 bricks, will he have enough to complete a job requiring 1,900 bricks? Now, we do not use the 1900 in the setup of this. We use the 2000, and we use the fact that we have 4.5% that will be broken. So it's basically 4.5% of the 2000. We're going to still use this formula that I've shown you and we've been using so far. So we are looking for how many broken bricks there will be if we order 2,000 bricks. So the is my unknown. 2,000 is the original number. It's 4.5% over 100, and then cross multiply. So 100x equals 9,000 when I multiply, right? The cross product, 2,000 times 4.5. So we find that there are going to be 90 approximately, you know this is an approximation, broken bricks. So since about 4.5% are broken, we can expect this to be fairly consistent, not exact. Well, if we have 90 broken bricks and we ordered 2,000, then we end up with 1,910 good bricks, right? Not broken. And so we do have enough because we have 10 extra, right? We have a little bit of leeway here. And so yes, 1,900 would be enough. 1,900 bricks. And you can answer that in different ways, but you do want to address that part because it says, will he have enough to complete a job that requires 1,900 bricks? Okay. So when I scroll and I get a blank page, I have to pause and shut this and open it back again to get it to show. Okay, so here's our next question. Year-end statistics for a community revealed that in 648 of the 965 residential burglaries, the burglar entered through an unlocked door or window. What percent of the entries were made in this way? Okay, so we are trying to figure out what percent 648 is of 965. So we're looking for the percent. That's going to be our x. And I think almost everyone knows that you would take 648 divided by 965 if you were just going to convert this without showing it the way I am. What this does for us is that we don't end up with a decimal number that we have to convert to a percent. Doing it this way takes care of that within the problem, right? So that's helpful so that you don't always have to do the converting. We have 965x equals 64,800 when we multiply by 100. And then we're going to divide by 965. And when you do that, you get 67.15. And then I don't really say it here, what percent, yeah, but let's just round that to the 10th spot. So 67.2 is how we will write that one. All right. Make sure that when I go to the next screen, or, you know, as we progress through the screens, that you would possibly pause it and try it. Now, the next question is actually a little something different here. We have several of these in our textbook about efficiency because that's kind of a real life application of percents. And so this one says electronics. A CB radio is rated at 7.5 watts, and actual measurements show that it delivers 4.8 watts to its antenna. What is the efficiency? So basically what it's saying is 100% efficiency would be 7.5 watts. This is not delivering 100% efficiency. So we have to figure out what is the efficiency of this. So the 4.8 is our output, our actual output, right? So that's 4.8 is my is. My original is 7.5, and that is the part that it's expected to do. And then we're looking for the percent out of 100. Okay, so we cross multiply. Divide by 7.5. And we find that our efficiency is 64%. So I'm going to write that. You don't have to write efficiency. I'm just going to write that as a little bit more of a label here to explain. And so when you find these, sometimes you'll be finding the percent, sometimes you'll be given the percent. So you just have to get everything into your formula because, you know, technically we're using this percent formula, and it's really just geared to help you be able to set these up. Okay. And this is another way to use the percent formula. But the percent of increase or decrease, the percent of a change. And so we actually work it out the same way. The actual increase or decrease is going to be subtraction. So we subtract and find the difference between the two numbers. This number, the original, that's super important that we put the original number. And so if it's an increase, the original number will be the smaller number. If it's a decrease, the original number will be the larger number. And then we're looking for on these our percent each time, right? What percent of increase or decrease happened here? Okay, so I'm going to underline some things in this if you read it. In 1976, new world records in the high jump, right? So this is how high they're jumping, were set for both men and women. Dwight Stones set the men's record at 232 meters. Okay, so the men's record, here, let's use green for men. The men's record was 232 meters, and then Rosemarie Ackerman set the women's record at 1.96 meters. And so I just realized I didn't change when I hit it and then I didn't hit it hard enough. Okay, so men here, women 1.96 meters. So not as high, you know, because the men jump higher than the women. The current record is 245 for men and 209 for women. Okay, and it tells you set those records. So 209 for the women and 245 for the men. So you see that there was an increase. Which record, men's or women's, has increased by the larger percent since 1976? Find the percent increase for each to the nearest tenth. Okay, so there's several steps on this. So let's work through the women. So first we take the two measurements for the women and we subtract, because we need to find the actual increase. So it increased by 0.13 meters. Okay, that's our increase. We're going to set this up then. My actual increase is 0.13. My original was 196, and that was back in 1976, so 1.96. Remember, it was an increase, so it's going to be the smaller value in the problem. And then we cross multiply. My 9 turned kind of wonky. 1.96x equals 13. We're going to divide by 1.96. And then we find that when we round this, we get about 6.6% for an increase. So the women's increased by 6.6%. Let's look at the men then. So for the men, we're going to take 2.45 and subtract 2.32, which gives us 0.13. So they have the same increase. However, the number we're dividing by is different than it was for the women. So we set up a proportion that's similar, but not quite the same, right? The original was 232. We're looking for X. So cross multiply. It also equals 13 there. We're going to divide by 2.32. And we find that X is approximately, when we round this, right, 5.6%. So that means that the women had the bigger increase, right? Bigger increase. And that would be the women. All right, so whenever you have a question like this, you want to be sure that you identify in some way which one was bigger, and you can circle it. You can talk about it like I did, women, bigger increase, however you want to do that. Okay, this is also a percent of increase or decrease. In the year 2000, the median annual earnings among 18 to 34-year-old Americans was $37,355, and then in 2013, their median earnings was $33,883. So there was a decrease. By what percent did they decrease? Okay. So first we subtract, and this is a place where you could pause and try to work through this problem. Pause the video and then check your work with me. So take the larger number and subtract the smaller one. You're not going to get negative numbers here. You're always going to do, here, I'm going to write that down here. So this was our decrease amount, right? That's the actual increase or decrease. So in our formula, we put it here. The original number was the 37,355. We are finding the percent. And of course, the 100 is the standard part of our equation or our formula. Cross multiply. And let's see, what do we get here? Oh yeah, we just add a couple zeros on there. And then divide. On both sides of our equation. And it says to round to the nearest tenth. So X is 9.29, and then when we round it, 9.3%, and remember that was a decrease. Okay. Well, we can't finish the rest of the problems on this video, so I'm going to stop this one, and then we'll have a third video to finish up this lesson.